Hello, and welcome to this tutorial for the Smallworks GPS Lure. Today we will be going through the installation and configuration of an NTP server using our semi-auto installer. Semi-auto because you as the user will need to change a few config files to match your system and also confirm a few downloads. First, start off by creating or downloading the install script in a directory of your choice. In addition to the install script, download or create a booting script. This file will run on every boot on the device to ensure proper setup and the linking of the modules. Be sure to pick a good location since your system will need to reference files in here later on for future boots. Once everything is in place, open up a terminal. In it, type in sudo I to ensure superuser status. Next, move into the directory where the script is with the cd command. Now, the last thing we need to do before we can run the script is make sure the permissions are correct. For this demonstration, we'll set permissions to full access, but you can change this as needed. With that done, go ahead and run the script. As it runs, you may be prompted to accept certain package installations, so be sure to check in from time to time in case you have to press yes. Once the packages are installed, the MinnowPPS GPIO file will open. This code serves as a driver to enable PPS support on the MinnowBoard. To configure it, scroll down and change this line so that it says PPS GPIO 340. This is the Linux address for the PPS pin on the Lure. Please note if your kernel version is 3.17 or earlier, the port number will be 84. With that change made, save and then exit Nano. This will now compile and install the PPS driver. Next, we add PPS as a module. In this modules file, simply go to a new line and type PPS-GPIO, then save and exit. At this step, the PPS should be fully installed and functional. The script will now set up and link the GPS signal input. Once complete, the Ntp Config File will open up. In this file, we will tell the NTP daemon where to find the PPS and GPS signals. First, scroll to the bottom. If the GPS and PPS lines are already there, uncomment them. Now, change the GPS server address to be 127.127.20.0. On the line that reads server, we will also change the mode to be 18, which tells the server to read the GGA sentences the GPS sends and read them at a 9600 baud rate. We will also add a min and max poll to tell the daemon how often to look for those times. Finally, we will add iburst and preferred to this line to make sure the NTP daemon looks for the GPS first for time, making this the primary time source. On the fudge line, set flag 1 to be 1, set flag 2 to be 0, and flag 3 to be 0 as well. These flags will enable PPS support, capture the PPS on the rising edge, and use the NTPD clock discipline respectively. Additionally to this line, we will tack on time 2, 0.0, and stratum 1. The time 2 is the time offset for your account to hardware delays. Once you allow your system to run for a while, if you notice a constant GPS offset, change this 0.0 to that value. The stratum 1 simply tells the daemon and other servers around the network that this clock is directly hooked up to the stratum 0 clock on the GPS satellite. Next, for the PPS, set the IP to be 127.127.22.0. And add on a min and max poll of 1 to the server line to get faster polling on the pulse. Additionally, on the fudge line, add ref ID PPS so NTP correctly labels this input. As an optional step, you can comment out or add reference servers online. It is generally a good idea to have at least one server or pool here to ensure same time is broadcasted in the event that the GPS signal is lost. One pool of servers is typically good enough. With these changes in place, save and exit. The next file to open up will be the user sbin ntbd file. This file is responsible for AppArmor, a program which limits other programs' abilities. This also blocks NTP from fully receiving the GPS data, so we will change this file to allow that. Scroll to the bottom and add a line or uncomment the existing one that says Capability IPC Owner. Once that's done, save and close the file. Finally, RC local will open. Find an empty line above the bottom and add in the address for the boot script from the very beginning. For this example, since our folder was on the desktop, we would type /home/ubuntu/desktop/autoscript/ntp config boot.sh. While it's ideal not to move this file, if you ever do need to move it, just change this line and the boot config will still work. With all this done, simply reboot the system and you will be up. Once you're back online, you should be able to run ntpq-p every few seconds to check that you're getting an offset and jitter value for the GPS and PPS. At first, these values may seem quite erratic, however, they will hone in over the next few days of running and eventually get down to be either less than a few milliseconds or even less than a few microseconds. With that, you should now have a functional Stratum 1 NTP clock. Congratulations!